Now from this point on in the rest of these Stargate lectures, um, we've really covered all of the core concepts of how this technology works, and we've covered a lot of geometry, and there really isn't much left to say. But so okay, from this point on, we're really going to be doing a lot more math. Okay. Um, okay, we know that the Stargate address has four points in it, four linear lines. We mentioned this before already. Okay, but exactly how do we explain those lines? How do we write them out, and so forth? Okay. Well, let's just start. Let's just start really simply. Okay. Our linear line passing through. Okay, let's have this as the center right here. Okay, it's passing through one side of the circle and going through the other side, and so on. How do we explain this in mathematical terms? If you went through high school algebra, you probably know this already. It's going to just be y. Okay, the y equals mx plus b. This is how every linear equation looks like. Okay, so we have the y in the x-axis, and okay, the slope of the line. The slope of the line actually is just our m, delta y over delta x. And now this is the other thing, maybe the thing that's very interesting. Okay, we have a point here. We have a point here, right? Technically, we could explain it using two different equations. However, it's really only one line. This is actually two different points on the Stargate address. Okay, these are different addressing nodes. However, it's all the same line, and it's very simple to see. Okay, that's a triangle, a right triangle actually, and this is this one equation will explain this line. Okay. Okay, so we have one linear line. We have node 1. We have node 2. These are our two address points. Okay, so I don't think it really gets any more simple than that. Okay, so one of the things that we need to kind of understand though. Okay, this is a circle more or less. We have 360 degrees. If we're going to use degrees and not radians, I prefer to use degrees. It's more geared towards navigation. And this is what we're doing, navigating through hyperspace. Okay, so we've got two points here. Obviously, this top half of the circle is going to be 0 degrees through 180 degrees. And this is going to be the same line. Okay, but if we want to make all of our calculations a lot more simple, we only need to calculate this slope right here. Okay, we just need to calculate this part right here, and then we know everything that we need to know. Okay, so in the different angular positions here, we are only going to be worrying about 0 through 180 degrees, because we can easily calculate what the angular measure of this part of the angle here will be. Let's just say if this is 20 degrees here, we know that this is a straight line. and that the measure of this angle right here is going to be 180 degrees plus this angle right here. So that's 200. This one right here, and it's going to be 200 degrees. All right, very simple. But like I said, the one thing we need to worry about in our equations is when we plug these degrees of the angle of the linear line into our Stargate equations, which we will learn about later. I'll actually write them out. We cannot have an angular measurement greater than 360 degrees. If we do, it's going to throw everything off. We get this really crazy, nonsensical answer. Generally, it's an answer that's a negative number, and you can't really have a negative number to space. It just doesn't work out unless you're going to be talking about, I don't know, maybe time travel or something. I will talk to you about that later, but only after we finish all of this math about the basic Stargate system. And just kind of as a teaser, I'm going to be explaining to you everything about the different kinds of technology we can create that can change our world based on this knowledge. Okay, so anyways, let's get back to our equations here. So really the total number of angular positions, the node angles in any given Stargate system, we have another equation for that also. It's very simple. T equals okay, it's like that. Just very simple. Okay, and that's how we like to keep it. Okay. Okay. Now, first you look at this, you might think this is really confusing, but later it's all going to come together. Really, all going to come together. See, this is the total, the angle right here. This is actually going to be the angle that we put into our Stargate equation, because obviously this P over N is going to just be the first tiny, the smallest measurement of an angle based on N. Obviously, we're only talking about the top half of the circle, so we need 180 of them. So, we have this very simple equation. All right, so that's all we have right now. Let me look into my notebook for anything that I might have missed. Yeah, there's really nothing more that you need to understand about this. Just know that in in a complete Stargate address, there will be 4 linear lines. Okay, each plane will actually have 2. Okay, I'm just going to go ahead and draw this other linear line here. So we have y1. Very early in this series of lectures, I told you that the first line is y1 and the second line is y2. So just go ahead and write this out for fun. And actually, let's be a little more mathematically accurate. So y1 is y1 equals mx plus b, and y2, this line, is going to be cx plus b. Obviously, we need to use a different variable here because obviously the angle is different, and this first term right here is our delta y over delta x, the angle, the change in slope. Okay, so that's really all we need to know about this so far. And probably in the next video or so, I'm actually going to go through and explain how we convert a regular y equals mx plus b linear equation into our Stargate equation, because we can't just we don't know what the slope is. We don't know what the y's and the x's are, and frankly, we don't care because that's the standard equation. We need a very specialized equation that will work for our Stargate system. And in order to do that, we're going to have to exploit some of the equations that we learned from trigonometry. For example, the law of sines. And we're going to be putting this linear equation into a different form, and it will be in the different form that will be using the law of sines. Okay? So, strap on your mathematical hats, because it's going to hurt. Maybe. Maybe, I don't know. But yeah. It's going to be your hard hat, your hard mathematical hat. And it's going to stretch some brain cells, probably. Okay? So, until then, defy the forces that be.